Okay, welcome back to trigonometry. We are faced with the polar curve. R is equal to 1 plus 2 cosine theta. We have to sketch the curve on an r theta Cartesian coordinate axis. We have to sketch the curve in polar, and then we have to figure out where does this graph intersect the origin. So what we're going to do is we're going to go ahead and draw a picture here. So we have our values here. Here's my theta axis. Here's my r axis. Here's 1. And we're just going to go ahead and draw a little dotted line sitting there because that's my new center line. And then when cosine is going to be something like 0, we have 1 plus 2. So we're going to be up here at 3. When cosine is equal to pi, cosine of pi is -1. So we have 1 minus 2. So we're going to be down here at -1. Okay. So we need our 2 pi. We need our pi. We need our pi over 2. We need our 3 pi over 2. And we're going to go ahead and graph this. So here's our cosine values. So back down to, cosine, when theta is pi over 2, we're going to be down 1 here. Cosine of pi over 2 is 0. So we have 1 plus 2 times 0. Okay. Down here, okay, back up to our value of 1. And then up here at cosine of 2 theta, or 2 pi rather. So we're going to be able to say this is our graph. Okay. And that's going to be our curve. Okay, so that's our Cartesian representation of this curve. Now we have to go ahead and put it on polar graphs, all right? So when theta is equal to 0, we're going to be a distance of 3 out. So 1, 2, 3, or 3 out. When we are a distance of pi over 2, or we are theta is equal to pi over 2, we're going to go down to a value of 1. So theta pi over 2 is going to be up here. We're just going to be up here at 1. Okay, so we're going to be something like that. All right, now here is the tricky part. Somewhere between theta equals pi over 2 and pi, so it's going to be somewhere in the second quadrant. It crosses over the axis, i.e. the origin, and then when we get to pi, we actually have to take a step backwards from pi. So here's pi. We have to take one step backwards. So we're actually going to be over here somewhere. So somewhere between pi over 2 and pi, this curve comes in and actually hits the origin, comes around and does a little loop-de-loop here. It's back around. Now, when theta is equal to 3 pi over 2, we are back out here at 1. So we're going to go at 3 pi over 2. We're going to come down 1 unit. And then from 3 pi over 2 back to 2 pi, we're going to go from 1 all the way out to 3 here, right? So this is what this graph of this thing should look like, right? Now, one of the questions that I have for you is, where did it enter? Like, where is it? What is the angle that this comes in? And what is the angle this comes out? Okay, so we want to figure out those two angles. And how are we going to do that? So what we're going to do is we're going to say 1 plus 2 cosine theta equals 0. We're going to solve for theta here. So we're going to say this is 2 cosine theta equals -1. Cosine theta is equal to -1/2. Okay, so we're over here somewhere. So it's going to be looking like a 60-degree or a pi over 3 kind of an angle. So theta, if you memorized your unit circle, is going to be 2 pi over 3, because we're in the second quadrant here, right? It's also going to happen in the third quadrant. Okay, so 2 pi over 3 and 4 pi over 3. Okay, so I'm counting around, saying 1 pi over 3 is about 60 degrees, 2 pi over 3, 20, 3 pi over 3, that's pi. I don't want that one. And 4 pi over 3. So I'm just counting on my fingers to count how many pi's over 3s we have to go along and do this. So this is going to be 60 and 60 is 120. And then 60 times 4 is 240 degrees. Both of these answers are going to be just fine. Okay, I'll take both of them. You have to give me both of the angles. Okay, so for full credit, you need both of these angles. But if you give them to me in degrees because you used your calculator, that's fine. You just have to realize, like, oh, we need in quadrant 3 and, or I'm sorry, quadrant 2 and in quadrant 3. So you have to know, like, you're counting around for this stuff. Okay, but either way you want to represent these angles to me, either in degrees or in radians, I'm okay with that. Okay, so that's how you do this kind of a problem. Here's our nice pretty graph. And then we have our Cartesian graph so we can kind of see what's happening with our polar graph. draw this thing in. Okay, so that's how you graph one of these problems. I'm going to say thank you very much for watching the video, and I will see you in the next one. Take care.